Okay, so now we know all these neat old like angle addition thingies. Big whoop. Why do we care about them? Here's why we care about them. Sine of 75 degrees. We'll go back to degrees just for a little bit here, just to kind of help us out. Sine of 75 degrees. I don't know that. I know 45. I know 30. I know 60. I know 90. Oh, I don't know anything about 75. If we convert it into radian too, that's not going to help us either. It becomes a pi over 12. Oh, I don't know that. Ah, dang it. Well, I guess we're sunk and we can't figure out its exact value. We can. We know, hey, 75, that is the same as 30 degrees plus 45 degrees. Ah, neat. So the sine of 30 degrees plus 45 degrees, that's the same as the sine of 75 degrees. Using our angle addition identity that we just learned about today, we can convert that into the sine of 30. And I've got this memorized. My hope is that you can get this memorized as soon as you can. But I know these don't match, but this does. Then I got to reverse it and do the other two angles. So a cosine of 30 degrees, and then the sine of 45 degrees. And I'm just getting that off of my trig identity sheet. You can see it. I'm going to go to it right up here. So I'm just using this. So I just copied all that down. But instead of an alpha and a beta, we have 30 and 45. Okay. Well, I actually don't know this very well in terms of degrees, but I do know it pretty well in terms of radian. The sine of 30 degrees, sine of 30 degrees is the sine of pi over 6. Sine of pi over 6 is 1/2. So that is 1/2. The cosine of 45 degrees, that's the square root of 2 over 2. That's the cosine of pi over 4. Then we got the cosine of 30 degrees. Cosine of 30 degrees is the same as the cosine of pi over 6. And the cosine of pi over 6 is square root of 3 over 2. And then finally, we've got the sine of 45 degrees. That's square root of 2 over 2 again. Now these are being multiplied and then added. We simplify all of this, the square root of 2 over 4 plus the square root of 6 over 4, which equals the square root of 2 plus the square root of 6 over 4. Now you might be tempted, like, ooh, that's square root of 2, square root of 6. Can we put those together? No, we can't. You technically can. There's some rigmarole you can do, but we're not going to bother with that. We got enough to deal with right now. And it is perfectly neat. Be careful that you don't accidentally add them together and make it a square root of 8. That is a big no-no. It is not the square root of 8. It has to stay separate. We're able to multiply radicals together. That square root of 3 and the square root of 2, we can put those together because they're being multiplied together. But the square root of 2 and the square root of 6, we can't, because you can't when they're added together. You can when they're multiplied, though. And that's it. We found the exact value. Your decimal, your calculator just spit out a decimal. We got the exact one. Okay, here's another one. I know cosine of 7 pi over 6. I could do that. I can do the sine of 7 pi over 6. I don't know the cosine of pi over 12. And I also don't know the sine of pi over 12. And also our golden nugget is pretty full. So I don't want to add the over 12s to it. I cannot be bothered. So instead, let's use our trig identities again to see if we can simplify this thing down into something we can deal with. So I've got sine, cosine. So that's telling me sine and cosine, those are different. So according to my trig identity sheet, I want to deal with sine, I believe. Let's go back and look. So I want sine, cosine, yep. And I want the inside to match. So negative, negative. So if they're being subtracted, I'm going to keep that subtracted. They're being added. So we are going to add those two fractions together. So instead of all this, we're going to make this the sine of 7 pi over 6 plus pi over 12. Okay. Well, I want to add those together, so I better get a common denominator. So that is the sine of 14 pi over 12 plus a pi over 12. So then we get the sine of 15 pi over 12. Ooh, 15 pi over 12, we can simplify that fraction. So that's the sine of 5 pi over 4 if I divide top and bottom by 4. Ooh, the sine of 5 pi over 12, that's easy. It's in quadrant 3, so it's negative. Reference angle pi over 4, so I'm going to do square root of 2 over 2. Woohoo! Done! So wraps up our section on angle addition. A reminder that these are going to do one of two things. They're either going to kind of like, you'll see a big mess and it'll whoop, shrink it real down real fast, or you'll see something pretty simple. We'll make it a bit of a mess, but then it will also shrink down again. A reminder that sine, watch these signs, sine does match, cosine does not. Tangent matches in its numerator, but does not match its sine in its denominator. Watch those pluses and minuses to make sure you wrote them on your paper correctly. Thanks. Bye-bye.